Here we're going to look at a number patterns and sequences related problem. So here's another challenge. So we need to prove that if the sequence T of n is both arithmetic and geometric at the same time, then T of n is equal to C for some constant C, or in other words, T of n is a constant sequence. Now if we were to write the first few terms of T of n as follows, so we have C, 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 and so on, one can notice that the sequence here is a arithmetic sequence with a common difference of 0, as well as a geometric sequence with common ratio of 1. Now let's get into the proof. Let me suppose that A, B, and C are three consecutive terms of T of n. According to the definition of an arithmetic sequence, the differences between any two consecutive terms must be constant. Or in other words, B minus A must be equal to C minus B, or rearranging we get that 2B is equal to A plus C. And by the definition of a geometric sequence, the ratio of any two consecutive terms must be a constant. Or in other words, B over A is equal to C over B, or this implies that B squared must be equal to A times C. Okay, now we have two equations. Notice that we can substitute the value of B in equation 1 to equation 2 here to get the following. So if A plus C squared over 4, since 2 squared will be 4, this will be equal to A times C. Or in other words, this implies that A plus C squared minus 4AC is equal to 0. Notice that we can expand A plus C squared, that will be A squared plus C squared plus 2AC minus 4AC. So we can rewrite this into minus 2AC is equal to 0. Or we can factor this again as A minus C squared is equal to 0, which implies that A must be equal to C. Now substituting this thing here into any of these two equations up here implies that B must also equal to A and C, which implies that since we can suppose that A, B, and C are any three consecutive terms, that means that our sequence right here must always be constant. Or in other words, each of these terms must be the same, which ends this video.